The morning sun cast long shadows across the test range at Aberdeen Proving Ground in Maryland on July the 10th, 1944. Three captured German Panzer IVs sat waiting on the hardened surface like specimens in a laboratory. Colonel William Christ stood 800 yards away, watching his crew position a standard 76mm gun. For 3 years, every single report filtering back from North Africa through Sicily and into Normandy told an identical story. German tanks were engineering marvels, built with superior armor and tolerances so tight they'd taken 7 years to perfect. American military doctrine had been constructed on one foundational belief: never engage a Panzer IV head-on. You would lose. Christ had survived Kasserine Pass. He'd stood helpless as 14 men in his battalion died fighting these machines. Every tank commander, every crew member believed the same thing he'd believed. German engineering was simply unbeatable. Then Captain James Riley, the metallurgist on his team, ran hardness tests on armor samples pulled from the captured vehicles. What Riley found in those tests changed everything. The welds weren't continuous solid bonds. They were tack welds, short interrupted spots placed every few inches with gaps separating them. Magnified under the laboratory lights, they looked like cottage cheese, full of voids and porosity and pre-existing cracks that had nothing whatsoever to do with combat damage. At 6:43 in the morning, the gun fired. One shot. Standard ammunition, the exact same rounds American crews had been firing all along. What happened in the next 0.3 of a second would rewrite every training manual in the entire European theater. 3 weeks had passed since the Normandy landings when a flatbed truck rolled through Aberdeen's gates carrying a machine every American tanker had been taught to fear with good reason. The Panzer IV was smaller than Colonel Christ expected it to be. The paint was scorched black from combat. Mud from the Norman bocage caked the tracks. Blood still stained the inside of the turret where the crew had bailed out somewhere near Carentan. 2 more arrived over the following week. One OSFG model captured in Tunisia and still bearing desert tan camouflage paint. Another late production J variant pulled from the hedgerow country, its glacis plate scarred with impact marks but showing no actual penetrations. Christ walked around the 1st Panzer deliberately, the way he'd learned to move through unfamiliar terrain before committing to an advance. At 42 years old, he headed the tank automotive branch at Aberdeen's Ballistics Research Laboratory. A slight limp reminded him of German shrapnel that had nearly claimed his left leg at Kasserine Pass. In his desk drawer, he kept a photograph from 1943 showing his crew. 4 names were circled in pencil. All 4 had been killed in action. He'd requested the transfer to Aberdeen with a single purpose. He needed to understand why German tanks seemed invincible. If they truly were superior, if American crews were dying because their equipment simply couldn't match German quality, then at least those deaths held meaning. But if they were dying for reasons that could have been prevented, if the enemy's reputation was built on perception rather than reality, then every casualty represented a failure of understanding and planning. He wasn't an engineer by training or education. He was a tanker who'd taught himself to read ballistics reports during long hospital stays, studying trajectory tables and penetration data while his leg slowly healed. The doctors had told him he'd never walk without a cane for the rest of his life. He proved them wrong through stubborn determination and repetitive effort. Now he applied that same principle to armor testing. Trust nothing, verify everything. Let the data speak its own truth. Every report arriving from the European theater painted the same picture. German tanks were technological marvels. The Panzer IV had been in continuous production since 1937, giving engineers 7 full years to perfect every component, while American factories rushed to churn out 2,000 Shermans per month. Assessments from the Ordnance Board based on combat reports from Tunisia, Sicily, and Italy all reached identical conclusions. The Panzer IV could engage and destroy a Sherman at distances where American 75mm guns couldn't reliably penetrate the armor. Tank doctrine had evolved around this reality. Bring superior numbers, use speed, exploit terrain. Never accept a head-to-head fight. Christ had believed it himself, as did every tanker in the army. The alternative was unthinkable. that hundreds of American crews had died fighting an enemy that wasn't actually superior at all, just assumed to be. Testing started immediately on the first day. His team measured weight distribution and armor thickness at 17 different points. They measured optical quality and interior layout. Everything was documented, everything was photographed, everything was measured to the thousandth of an inch. By the third day, they'd progressed to hardness testing using standard Brinell procedures where a carbide ball presses into steel and the indentation depth reveals the material's hardness. The frontal armor read between 265 and 280 on the Brinell scale. American homogeneous armor typically ran between 240 and 260 for comparable protection levels. Captain James Riley, the metallurgist, didn't look up from his calipers. "Good steel," he said, "but look at this." He pointed to the weld seam that joined the frontal plate to the side hull. Under the harsh fluorescent lighting of the testing bay, something looked decidedly wrong. The weld wasn't continuous. It consisted of short tack welds spaced every 3 or 4 inches with gaps between them. The quality was inconsistent throughout. Porosity bubbles were visible even without magnification. Voids marked places where metal hadn't fused properly. Christ leaned closer. Battle damage? They checked the other 2 Panzers. Same pattern appeared on both vehicles. Discontinuous tack welds everywhere. Porosity at most joints. Slag inclusions. Impurities trapped inside the weld metal. The late Model J even showed visible cracks in one frontal plate seam, cracks that clearly predated any combat. The oxidation patterns around the crack indicated it had been there for weeks, possibly since manufacture. Riley straightened up, still holding his magnifying glass. "Colonel, I don't think this is battle damage. I think this is how they built them." Christ ordered comprehensive metallurgical analysis. Over the next week, Riley's team cut samples from all 3 vehicles. They performed tensile strength tests. They examined the grain structure under microscopes. They ran Charpy impact tests to measure how the steel behaved under shock loading. The results landed on Christ's desk on July the 10th. The armor wasn't just hard, it was brittle. Riley's report used the word embrittled 7 separate times. The steel had been heat-treated to maximize surface hardness, pushed past the point of resilience. Hard enough to resist penetration at shallow angles, but vulnerable to catastrophic failure under direct impact, like glass. The metallurgist included photomicrographs showing the grain structure. Coarse angular crystals indicated improper heat treatment. American armor showed fine uniform grains that could absorb impact energy without shattering. The welds were worse. Complete fusion had failed in 34% of the samples. The weld metal hadn't fully bonded to the base plate. Slag filled the seams throughout. Porosity suggested welding had been done too fast without proper gas shielding to prevent oxidation. Some welds showed pre-existing crack initiation points before any test firing ever occurred. The bolted joints on the earlier OSF-G model presented their own nightmare scenario. 47 separate bolted connections fastened the crew compartment together, each using 12mm grade 8 steel bolts. Riley's team had tested them thoroughly. Under impact shock, the bolts sheared, transforming fasteners into deadly projectiles, moving inside the crew space. Each bolt head weighed 3 ounces and possessed sharp edges, designed only for assembly. Christ read the report twice, then picked up the phone to reach the test range. "Tomorrow morning," he said, "live fire against the OSF-H. I want to see what actually happens when we hit this thing." That night, sleep eluded him. He kept thinking about Kasserine Pass, about the 14 names, about every after-action report attributing American losses to German technological superiority. What if they'd all been wrong? What if American tankers had been dying, not because German engineering was superior, but because no one had ever bothered to properly test the assumption? What if German superiority was mythology, repeated until it became doctrine, accepted as truth simply because questioning it felt like admitting weakness? At 5:30 in the morning, he was already at the range, watching the captured Panzer IV positioned 800 yards downrange. The same distance where American tanks had burned in North Africa. The same range where his crew had died. Today they would see what the Panzer IV could actually survive when hit by weapons American crews carried into combat every single day. Today the numbers would speak for themselves. The captured Panzer IV, designated OSF-H, sat on the test range on July 12, 1944, at 6:30 in the morning. The temperature was 68 degrees Fahrenheit, with negligible wind. Serial number 87304, the tank showed approximately 3,200 miles of combat mileage based on trackwear analysis. The firing platform was an M18 Hellcat tank destroyer mounting a 76mm M1A1 gun. The ammunition was an M62 armor-piercing capped round, standard issue, weighing 15 pounds with a muzzle velocity of 2,600 feet per second. The target point was the center of the frontal glacis plate, slightly right of the driver's position, the thickest part of the tank. The part where doctrine insisted penetration was impossible at this range. Colonel Christ stood behind the firing line with Captain Riley, 3 ordnance test officers, 2 combat tankers from 2nd Armored Division sent to observe, and a Signal Corps photographer. Based on ballistic calculations, the M62 round should penetrate 92 millimeters of homogeneous armor at 800 yards when striking at approximately 30 degrees from perpendicular. The Panzer IV's frontal plate measured 80 millimeters at a 10-degree inclination. Theoretically, it lay within the penetration envelope, but barely. Conventional wisdom held that one shot would punch through and maybe cause some spalling inside, disable the tank, achieve a clean kill. The test was designed to confirm that 76mm guns were adequate against Panzer IVs at medium range. Nothing more. At 6:43, the M18 fired. The flash came first. The crack followed, 1 second of silence as the round crossed 800 yards at 2,600 feet per second. Impact. What happened next consumed 0.3 of a second, but would be studied for the next 6 months. The round struck the frontal plate 2 inches right of center. Penetration occurred. The hardened steel tip punched through the 80mm plate, creating a 3-inch entry hole. That part matched predictions. Everything else contradicted them. The entire frontal plate, 38 inches wide, 24 inches tall, 441 pounds of supposedly hardened armor steel, separated from the hull. It didn't break at the impact point. It separated at the weld seams. The plate didn't fall straight down. It pitched forward, still attached at the bottom by a single section of weld, like a drawbridge dropping open. The morning sun caught it as it swung. It flashed off the interior face. Through binoculars, Riley watched the weld seams give way. They weren't torn or sheared. They simply let go, failing completely as the plate tried to absorb impact energy and found no structural support. "Jesus Christ," whispered one of the 2nd Armored Tankers, Sergeant Frank Novak, 26 years old, 6 months of combat across France. The whole front just fell off. The test crew drove to the Panzer in a jeep. Christ was out before it fully stopped. The frontal plate hung from the bottom weld seam, exposing the tank's interior like a dollhouse with the front wall removed. You could see straight through into the engine compartment. The interior face of the fallen plate told the real story. 23 separate fragments of steel had broken loose from the inner surface, spalling caused by the shock of impact. The largest fragment measured 4 inches long and weighed 7 ounces. The smallest were quarter-sized. Every edge was sharp and jagged. Riley used calipers to measure impact craters on the opposite wall where fragments had embedded themselves. Fragments had traveled between 8 and 23 feet from the point of impact, suggesting velocities between 600 and 900 feet per second. Rifle bullet velocity. The Panzer IV crew compartment measured 8 feet long and 6 feet wide. 5 men worked in that confined space. 23 fragments moving at rifle speed in random directions meant every crew member would have been struck multiple times. But that wasn't the worst part. Riley examined the weld seam with his magnifying glass, then looked up at Christ. "Colonel, this weld was already cracked before we shot it. See these oxidation patterns inside the crack? This has been there for weeks, maybe since manufacture. The impact shock just finished what was already failing." The test crew stood silent around the gutted Panzer. Somewhere in Normandy right then, American tankers were engaging Panthers and Panzer IVs in the hedgerows, following doctrine that said avoid frontal engagement because you'll lose. Casualties were expected. You had to maneuver to flank positions. Sergeant Novak spoke first. "Sir, we've been told don't go head-to-head with the Panzer IV. The doctrine is flank. Use numbers. Accept casualties to get into position." He pointed at the exposed hull. "But this says we can kill them from the front at 800 yards with one shot." "Not just kill them, catastrophically." Christ nodded slowly. "If the welds are this weak across the board," Riley said, voicing what they were all thinking, "if this isn't an isolated case, then we test the other two." Over the next 3 days, Christ's team conducted 47 separate firing tests against the 3 captured Panzers. Different ranges, 500, 800, 1,200 yards. Different impact angles, head-on, 30 degrees, 45 degrees. Different weapons, the 75mm from an M4 Sherman, the 76mm from an M18, the 3-inch gun from an M10 tank destroyer. The results accumulated in black and white photographs that would become Exhibit A in a classified report to Washington. At 500 yards, a 75mm M3 gun, standard Sherman armament, caused weld failure on the side glacis plate. The plate didn't completely separate, but bowed outward 4 inches. A second shot in the same location caused complete separation. At 800 yards, the 76mm gun caused frontal plate failure in 3 out of 3 attempts on different sections of the test vehicles. Average spalling, 19 fragments per shot. At 200 yards, penetration was inconsistent, but shock-induced weld cracking occurred in 7 out of 10 shots. The 3-inch gun at 500 yards didn't just penetrate. It caused a fracture crack to propagate 18 inches along the armor plate from the point of impact. The plate literally broke like ceramic. July 15th came. Christ compiled preliminary findings into a 3-page memorandum marked urgent. Panzer IV armor hardened to the point of brittleness and prone to catastrophic failure. The weld pattern revealed something deeply troubling. It was systematically compromised, failing under the sharp shock of impact rounds even when they didn't punch through the steel. What happened inside the tank proved even more devastating. The interior face of the armor was spalling violently, sending razor-sharp fragments flying through the crew compartment at lethal velocities. These weren't glancing blows, they were clean impacts from non-penetrating hits. American 76mm guns and 3-inch cannons proved they could reliably tear through Panzer IV frontal armor at the ranges tankers actually fought at in combat. The existing doctrine of steering clear of head-on attacks was built on incomplete information. Worse, it might be costing American lives unnecessarily. Colonel Christ sealed the envelope with all the evidence inside. He arranged for a courier to get it to the Ordnance Department in Washington as quickly as possible. That same evening, his telephone rang. The voice on the other end belonged to Brigadier General Gladian Barnes, who oversaw research and development. "Colonel, I need absolute certainty on this," Barnes said, his tone grave. "Because if you're right, we're tearing up the training manuals. If you're wrong, we're sending American tankers to their deaths." Christ stared at the photographs scattered across his desk, the twisted armor plate, the shower of spalling fragments frozen in still images, the catastrophic weld failures. "Sir, I'm telling you the truth. The pictures don't deceive anyone. The numbers don't either." "This Panzer IV isn't what we've been told it is," Christ replied. Barnes fell silent for several seconds before responding. "Then demonstrate it. I want comprehensive testing. Every system, every weak point, full documentation before this month ends. Colonel, if you're right about this testing program might matter more than anything else we do in this entire war." For 16 intense days, Colonel Christ's team methodically took apart the captured Panzer IVs. Every bolt was catalogued, every weld was examined, every component was tested to destruction. What they uncovered was a comprehensive record of failures, a pattern that explained not just why the tanks broke down so easily, but how German manufacturing had managed to build something that appeared terrifying on paper, while containing fundamental structural flaws. Captain Riley oversaw the metallurgy work, running the armor samples through complete chemical and physical analysis. All three tanks told the same story. The Panzer IV relied on face-hardened armor, steel that had been heat-treated to create an incredibly hard outer layer, with the interior kept tougher and more flexible to absorb shock. The theory sounded solid. A hard outer surface would shatter incoming rounds. The resilient backing would absorb the energy from that shattering. But German manufacturing had botched the execution in critical ways. This hardening process demanded precise temperature control. The steel needed heating to exactly 1050 degrees Fahrenheit, then rapid cooling, followed by careful tempering at 450 to 500 degrees. The ASH and J models showed evidence that temperature control had been inconsistent at best. Different sections of the same armor plate measured completely different hardness levels. Some sections read 285 on the Brinell hardness scale. Others dropped all the way down to 245. The variation pointed to rushed manufacturing with inadequate quality oversight. But the more dangerous problem was that the hardened surface itself was too hard. Rockwell C testing found hardness readings on the surface ranging from 60 to 63, harder than the job actually required. That excessive hardness made the steel brittle instead of resilient. American homogeneous armor typically tested at Rockwell C 42 to 48, hard enough to resist penetration, but tough enough to absorb the shock of impact without cracking apart. Riley set up a demonstration that made the difference instantly obvious. He took a sample of Panzer IV armor and placed it alongside a piece of American Sherman armor in a drop test apparatus. Both samples measured 80 millimeters thick. A 50-pound weight dropped from 10 feet onto each one. The American armor dented, the German armor cracked. It's metallurgical over-engineering, Riley explained to his team. They made it so hard, they actually made it weak. The metallurgical examination revealed systematic problems across all three of the captured vehicles. German tank designers had relied on tack welding throughout their construction, short, discontinuous welds placed at intervals rather than running continuous beads. The logic seemed sound at the time: faster production, less welding rod consumed, less heat that might warp the armor plates. The reality turned out differently. These discontinuous welds created stress concentration points everywhere they terminated. When a tank took a direct hit, the impact shock had to travel through these welds. The broken, interrupted welds acted exactly like perforations in paper. The armor wanted to tear along them as stress redistributed through the joint. X-ray analysis revealed porosity in 68% of the weld samples examined, complete fusion failures in 34%. Slag inclusions in 52%. 23% already contained crack initiation points before any combat damage occurred. The late-war AUS-FJ variant was particularly bad, showing evidence of what Riley called crisis welding. Seams that had been rushed, poorly executed, never properly inspected. One of the frontal hull welds had a 4-inch section where the fusion was only 40% complete. Essentially, a pre-existing crack just waiting for combat stress to finish opening it up. The earlier Panzer IV models had faced a completely different problem that proved equally lethal. The AOSFG captured in Tunisia used bolted connections instead of welds, a design choice that made sense in 1940 when welding technology was still developing. But by 1944, it had become a death trap. The test team counted 47 separate bolted connections just in the crew compartment alone. Each bolt was 12 millimeters in diameter, grade 8 steel, with a tensile strength of 150,000 pounds per square inch. They devised a straightforward test: fire a non-penetrating 75 millimeter round directly at the external face of one of the bolted armor plates. The round didn't penetrate, but the impact shock traveled through that plate and sheared 60% of the bolts off. The bolt heads, transformed into projectiles, rocketed across the crew compartment at speeds between 300 and 600 feet per second. Sergeant Novak held one of the sheared bolt heads in his palm, about the size of a quarter, weighing 3 ounces, with sharp, jagged edges from where it had snapped free. "So even if the round doesn't get through," he said quietly, "the crew gets killed by their own tank." Christ confirmed it with grim certainty. "Exactly." Beyond the armor itself, the Panzer IV's interior layout magnified every vulnerability. The crew compartment measured just 8 feet long, 6 feet wide, 5 feet tall. 5 men had to work inside this confined space: driver, radio operator, commander, gunner, and loader. Every surface was bare steel or cast iron with no padding whatsoever. When spalling fragments tore free from the armor's interior surface, they had nowhere to go except through the crew. The test team calculated the fragment distribution pattern. At an 800-yard combat range, a successful penetrating hit generated an average of 19 fragments, each weighing between 2 and 7 ounces. Inside an 8 by 6 by 5 foot volume, that meant roughly 1 fragment per 12.6 cubic feet of space. By comparison, a Sherman's crew compartment was 9 by 7 by 6 feet, 26% more volume for the exact same 5-man crew. The ammunition storage situation made it exponentially worse. Unlike American tanks that used wet stowage ammunition containers filled with glycerin, Panzer IV rounds sat in simple bins along both sides of the hull. When spalling occurred, fragments struck that ammunition directly. The test team documented 7 separate instances where spalling fragments had punched holes in propellant cases. If that happens during actual combat, Riley noted, you get an ammunition fire that you can't control. The crew gets maybe 3 seconds to get out, and that's if the hatches aren't jammed shut by hull deformation. The team then evaluated the vision and sighting systems. The commander's cupola featured 6 3-inch vision blocks, small, thick glass ports that gave minimal field of view. With the hatches closed, the total horizontal viewing arc was only 240 degrees, leaving a 120-degree dead zone directly behind the tank. The Sherman's commander cupola provided 360-degree vision. The gunner used a TZ-F5F2 scope with 2.5 times magnification and a 25-degree field of view. Effective enough, but the mounting was completely rigid. If the tank hit rough terrain, the gunner lost his sight picture and had to search to reacquire the target. Sherman gunners had stabilization to keep their sights steady. Most telling was the late-war AUSF-J variant, with its manually hand-cranked turret traverse. No hydraulic power system at all. The test team timed it meticulously, 80 seconds to rotate the turret through 180 degrees by turning a hand crank. A Sherman with hydraulic power traverse could complete the same 180-degree turn in just 12 seconds. So if you're suddenly ambushed and the enemy appears on your flank, Novak said slowly, thinking through the tactical implications, you're spending over a full minute cranking that handle before you can aim at him. Christ finished the thought for him, or you die trying. By July 28th, the testing was finished. 127 rounds had been fired at the 3 captured vehicles. 43 separate metallurgical analyses had been conducted. 78 distinct design weaknesses had been documented. Every failure mode was photographed. The evidence was overwhelming and undeniable. The Panzer IV wasn't the technological masterpiece everyone assumed. It was a flawed design, poorly manufactured, held together only by mythology and American misconceptions. Christ wrote the executive summary personally, distilling everything into clear, unambiguous language. The Panzer IV demonstrates inferior metallurgy, inadequate quality control, and design compromises that render it substantially more vulnerable than previously understood. American tank destroyers equipped with 76mm guns can reliably penetrate Panzer IV frontal armor at combat ranges of 500 to 200 yards, with high probability of creating catastrophic crew casualties. Current doctrine of avoiding frontal engagement is not supported by empirical evidence and requires immediate revision. He signed it, dated it July 30th, 1944, and forwarded it to Washington. 2 days later, on August 2nd, Christ received a classified communication from European Theatre of Operations headquarters. The Germans had introduced the Panther tank in substantial numbers. Intelligence reports from Normandy painted a grim picture. American 75mm guns were proving ineffective against its frontal armor, even at relatively close ranges. Tank losses were climbing daily, and some commanders had read Christ's Aberdeen findings and were pushing back against acceptance of his conclusions. Some argued that the captured tanks tested in Maryland might have been specially selected or damaged vehicles that didn't represent standard German production. Others worried that endorsing frontal engagements would send tankers into unnecessary slaughter. One message from a division commander operating in France was brutally direct. The proof happens in the field, not in Maryland laboratories. The Panzer IV has destroyed hundreds of American tanks already. I will not gamble my soldiers' lives on what some scientists concluded in a testing facility. Christ read it and felt the familiar frustration rising, the same feeling he'd experienced after Kasserine Pass. The data was conclusive. The photographs were irrefutable, but institutional inertia, that invisible force that resists change, was proving just as powerful as any enemy weapon. How do you fight against mythology? How do you persuade people when the myth is comfortable? How do you change doctrine when doing so means admitting that years of accepted wisdom was wrong? How do you convince experienced field commanders that their own combat experience might be misleading them about the enemy's actual capabilities? By September 1944, the Aberdeen report circulated through the European theatre as a classified technical bulletin titled Ballistic Performance and Structural Vulnerabilities of Captured German AFVs. Initially, most field commanders greeted it with skepticism. The report directly contradicted 3 years of tactical doctrine, but gradually a few units began experimenting with what it suggested. The 634th Tank Destroyer Battalion, equipped with M18 Hellcats mounting 76mm guns, received the report in early September. Their commanding officer, Lieutenant Colonel Samuel Hogan, had been a chemistry teacher before the war and had retained his belief in empirical evidence. Based on Aberdeen's findings, Hogan issued new tactical guidance to his crews. Engage Panzer IVs frontally at 600 to 1,000 yards with confidence. When possible, aim for weld seams and plate joints. Expect a catastrophic kill on the first shot. Do not waste secondary rounds. Trust your weapon. On September 19th, near Aachen, Germany, the 634th encountered 2 Panzer IVs in a frontal engagement at exactly 750 yards, precisely the scenario that older doctrine had said to avoid. Following Hogan's orders, 2 Hellcats engaged head-on. 4 shots were fired total. Both enemy tanks were destroyed. One showed the characteristic weld failure. The frontal plate had separated from the hull. The other displayed armor fracture at the impact point, the crack propagating outward along the plate edge. American casualties, 0. The after-action report reached Christ's desk on October the 3rd. Throughout September and October, similar reports accumulated from different units. The 702nd Tank Destroyer Battalion, operating with M10 tank destroyers mounting 3-inch guns. 11 separate frontal engagements against Panzer IVs. 11 confirmed kills, average of 1.3 shots needed per kill. The 2nd Armored Division, with M4 Shermans carrying 76mm guns. 8 frontal engagements, 7 confirmed kills, 1 mobility kill. The 771st Tank Destroyer Battalion documented weld failures on 2 separate Panzer IVs at ranges exceeding 1,000 yards. Each report included photographs of destroyed vehicles. Christ created a wall chart in his office, tracking every single instance of field confirmation. Between September the 1st and November the 30th, 47 separate Panzer IVs had been engaged in the European theatre. 31 showed visible weld separation. 19 showed armor fracture patterns consistent with his testing predictions. 38 showed severe interior spalling damage visible through the penetration holes. 42 had been killed by frontal hits. The field data from France and Germany confirmed everything that Aberdeen had proven in Maryland. The Panzer IV's reputation far exceeded its actual performance. In October 1944, Christ received notification of a significant discovery. A completely factory-fresh Panzer IV, an AUSFJ to match what he'd been testing, serial number 96743, had been captured near Metz. This tank had 0 combat miles. Its crew had abandoned it during the retreat before it ever fired a single shot. Christ's team completely disassembled this pristine example. The welds showed identical porosity and incomplete fusion to the earlier test vehicles. This wasn't damage from battle or neglect during maintenance. This was how German tanks came from the factory. The armor plate bore the unmistakable marks of wartime production. Stamped clearly into the metal were the identifying codes. Krupp, Magdeburg, July 1944. It was a snapshot of German manufacturing at a critical moment. 3 years into the war, the Reich's industrial capacity was buckling under relentless bombing campaigns while raw materials grew increasingly scarce. Riley's metallurgical examination would expose the devastating truth hidden within that steel. The analysis revealed catastrophic compromises in the metal's composition. Nickel content came in at just 0.6%, far below the 2 to 3% standard for quality armor steel. Nickel was essential. It prevented the steel from becoming brittle under the shocking impacts of combat. Instead, the Germans had substituted manganese in higher quantities, hoping to compensate. But the chemistry didn't cooperate. The substitution made the armor more vulnerable to fracture, not more resistant. They were running out of materials, Riley explained to his colleagues. They're attempting to maintain hardness with inferior steel. The mathematics simply don't work. The documentary evidence painted a stark picture. By late 1942, German supplies of chromium and nickel had dried up completely. Synthetic alternatives and salvaged scrap couldn't bridge the gap. The metallurgical standards that had defined German engineering excellence before the war were becoming impossible to maintain. Every tank manufactured after mid-1943 carried progressively degraded materials in its hull. By November 1944, the decline had become systematic. The Ordnance Department's statistical review of American tank casualties in Europe told an extraordinary story. From June through August, before Aberdeen's findings reached the field, 347 M4 Shermans had been destroyed or damaged in engagements with Panzer IVs. Those battles had claimed 523 crewmen. Then doctrine changed. From September through November, the numbers shifted dramatically. 89 Shermans lost, 127 casualties. The improvement was staggering. 74% fewer tank losses, 76% fewer men killed or wounded. Certainly some of this reflected the grinding reality of German decline, fewer operational Panzers available, diminishing reserves, production collapsing. But the after-action reports consistently showed something different. American tactics had transformed. More frontal assaults, more aggressive positioning, crews fighting with newfound confidence. A report from the 3rd Armored Division captured it plainly. Since receiving technical bulletin on Panzer IV vulnerabilities, crews no longer hesitate to engage frontally at medium range. Result has been faster target engagement and improved casualty ratios. The implications haunted him. If Aberdeen's research had been available in June 1944, if the testing had begun a full year earlier, approximately 400 American tankers would have returned home instead of coming back in body bags or not coming back at all. 400 lives. The weight of that number pressed down on him like the photograph secured in his desk drawer. The letter arrived in December 1944. It came from Sergeant Frank Novak, the tanker who had witnessed that first test back in July at the proving ground. Colonel, thought you'd want to know. Yesterday we got into it with 3 Mark IVs near Düren. Range about 900 yards, frontal engagement, exactly the kind of scenario we used to avoid at all costs. I remembered what you proved at Aberdeen. We engaged, all 3 destroyed in under 2 minutes. My gunner punched the first one directly through the front plate, and the entire frontal section separated like you showed in your tests. We could see through to the other side. For years we were told German tanks were superior to ours. Better armor, better firepower, better engineering. You proved that narrative was false. You demonstrated our weapons were sufficient and the enemy had vulnerabilities. That changed everything. Sir, there are 4 men in my crew who made it home alive because you refused to accept the mythology. I wanted you to know that. Chris folded the letter carefully and placed it beside the photograph. His crew from 1943, 4 names circled in pen. The men who had fallen at Kasserine Pass, victims of a myth they believed in absolutely. They died convinced German tanks were unstoppable. Then, December 16th arrived. The bulge opened with shocking force. German armor poured through the Ardennes. Panthers, Tigers, Panzer IVs, and the American lines shattered under the assault. Units were surrounded, overrun, driven backward in confusion. The casualty reports streaming into Washington were horrifying, and Chris heard the old familiar voices returning, whispering the same doubts. German armor superiority. American technical disadvantage. We need heavier tanks. The mythology, it seemed, had never truly died. It had only been sleeping, waiting for crisis to awaken it. He sat in his office at Aberdeen, watching snow accumulate on the test range beyond the window. The gutted Panzer IV hulks were gone now, cut into scrap metal, but the evidence remained. The data sheets, the photographs, the precise measurements, the undeniable proof. Yet proof meant nothing if institutions refused to accept it. How many additional men would perish before people finally understood that numbers cannot deceive, that solid evidence defeats mythology, that the true danger comes not from the enemy with the thickest armor, but from the adversary you're too fearful to truly examine. January 1945 arrived with grim statistics. 19,000 American casualties, hundreds of tanks destroyed in the Bulge offensive. The shock had triggered waves of recrimination about American armor capabilities. Some commanders demanded emergency production of heavier tanks. Others pushed to pull frontline units from combat until vehicles could be reinforced with additional armor. German superiority had surged back with renewed force. But something unexpected happened this time. Intelligence officers sifting through the wreckage from Belgium made a startling discovery. Of the 67 Panzer IVs destroyed across the Ardennes, 54 exhibited the identical failure patterns documented at Aberdeen. Weld separations in 38 vehicles. Armor fractures in 29, catastrophic spalling in 47. The physical evidence from the Belgian battlefield confirmed exactly what the laboratory had proven in Maryland. Under actual combat conditions, in terrible weather, during a surprise assault, American weapons performed precisely as Aberdeen's testing had predicted. The 740th Tank Battalion recorded a particularly telling moment on January 8 near Borstia. 4 M4 Shermans encountered 5 Panzer IVs at dawn. Visibility restricted to 400 yards in dense fog. Frontal engagement with no opportunity to maneuver. American crews trained on Aberdeen's findings responded immediately. 7 minutes elapsed. All 5 Panzers destroyed. 0 American losses. The battalion report included commentary from Staff Sergeant John Roller, tank commander. We hit the first Panzer IV in the frontal hull. The armor plate folded back like aluminum. The crew bailed immediately. After that, it was simply target practice. The Aberdeen data was accurate. These vehicles collapse when struck properly. February 1945 brought a turning point. The Ordnance Department released Technical Manual 9/1985A, German Tank Vulnerabilities and Engagement Doctrine. The entire manual rested on Chris's Aberdeen testing, enhanced with field observations from over 200 engagements across the European theatre. Every tank unit in Europe received copies. The manual contained armor quality analysis with specific hardness measurements and failure modes. Recommended engagement distances for different American weapons. Weld location diagrams highlighting vulnerable points. Photographic documentation of failure patterns. Statistical analysis showing kill probability at various ranges. The manual transcended simple data. It provided confidence. It told American tankers your weapons are sufficient, the adversary has weaknesses, trust the engineering. By March, doctrine had shifted entirely. American tankers engaged German armor with the assurance German crews had once possessed. That same month, Aberdeen received an intelligence package. Inside was a captured German military document from the Ruhr pocket. An internal Wehrmacht technical bulletin dated November 1944, marked top secret. The title, Qualitätsmängel bei Panzerkampfwagen Fertigung, Quality Defects in Panzer Production. The document was devastating. German ordnance officers had identified the identical problems Aberdeen's team had discovered. Schweißfestigkeit unzureichend. Weld strength insufficient. Panzerplattenseite zeigt Spritbruchanfälligkeit. Armor exhibits brittle fracture susceptibility. Materialqualität nimmt aufgrund von Grundlegierungsmängel ab. Material quality declining from alloying deficiency. The Germans understood. Their own engineers had documented the failures. But institutional rigidity, production deadlines, and pride in German engineering excellence prevented corrections. When Riley translated the document, one passage struck Chris forcefully. It is estimated that 60 to 70% of Panzer Kampfwagen exhibit weld defects that may lead to plate detachment under combat conditions. 60 to 70%, the Germans' own estimate precisely matched Aberdeen's laboratory findings. Both nations possessed the data, both had evidence. Only one chose to use it to save lives. April 1945 arrived as the European war approached its conclusion. American armor advanced through Germany with remarkably reduced losses. Panzer units, starved of fuel and replacement vehicles, no longer posed strategic threats. Chris reviewed casualty statistics for the first quarter of 1945. Tank losses to Panzer fire, 23 vehicles compared to 347 in the same period of 1944. Crew casualties from Panzer engagements, 31 men compared to 523 in 1944. The reduction transcended simple attrition of German forces. It reflected superior doctrine, enhanced tactics, and crews understanding the enemy possessed vulnerabilities. May 8th arrived. Victory in Europe. Colonel Chris returned to the Aberdeen test range, where this entire journey had begun. The range lay empty and still, only wind disturbing the scorched earth where so many rounds had impacted. He considered Kasserine, the 14 names, Frank Novak's letter, the 400 tankers who might have survived if testing had started earlier. The war had demonstrated something beyond ballistics and metallurgy. Mythology could kill as efficiently as any weapon. But evidence methodically collected and honestly reported could shatter even entrenched myths. The Panzer IV was never the magnificent machine German doctrine proclaimed. It was flawed, poorly constructed, sustained by fear and assumption. American weapons had always been adequate. American tankers had never faced superior technology. They simply required verification. Someone had to prove it. June 1945 brought a request from the War Department. Similar vulnerability testing was needed for captured Japanese tanks. Chris smiled. The methodology works. Evidence matters. Numbers never deceive. He approved the testing program and assigned Captain Riley to direct it. Before Riley departed for the Pacific, Chris provided a single instruction. Test everything. Question everything. If data contradicts accepted doctrine, report it regardless. Lives depend on accuracy. The photograph in his desk drawer remained undisturbed. 4 names circled, men from 1943. Kasserine Pass. Chris couldn't resurrect them. Couldn't alter what occurred, but he could ensure their sacrifice bore meaning. The lesson would endure. Future tankers would enter combat carrying not merely adequate weapons, but accurate knowledge. Mythology would never again claim American lives when factual evidence existed to refute it. The Panzer IV had never embodied the engineering perfection German doctrine claimed. It represented a myth nobody questioned. Aberdeen proved something fundamental. The most critical weapon in warfare isn't the largest gun or thickest armor. It's the courage to challenge what everyone assumes is true. One captured tank, one rigorous test, one officer who rejected comfortable falsehoods. Hundreds of American tankers returned home. That constitutes the legacy. That remains the proof that evidence defeats mythology unfailingly. It reminds us that in warfare, as in life, the deadliest deception is the one we're too comfortable questioning.